Have you ever wondered? Why do machines wear out over time? Why do engines lose efficiency even if we use the best oil and maintenance? It's not bad design, it's the universe's rule called entropy, the hidden law of disorder. Hey everyone! Welcome back to AxlePoint, where we break down engineering and industrial concepts in the simplest way possible. Today, we're exploring entropy, the reason why no machine can ever be 100% efficient, and why everything, from engines to bearings, slowly wears out with time. Don't worry, we'll make it easy to understand, even if you're in 6th grade. What is entropy? Entropy simply means disorder or randomness. It tells us how energy and matter spread out over time. When things are organized, like fuel neatly stored or energy tightly packed, entropy is low. But when things spread out, like heat or gases mixing, entropy becomes high. In short, ordered system equals low entropy. Disordered system equals high entropy, and the second law of thermodynamics says that entropy in the universe always increases, meaning things naturally move from order to disorder. For example, car engine, thermal entropy. Let's take a car engine as our first example. When fuel burns inside the cylinder, it produces hot gases that push the piston. That's useful energy doing work. But not all the energy turns into motion. A big portion escapes as heat through the exhaust and engine block. That lost energy is entropy. It's still energy, but too spread out to be reused for work. That's why no engine can ever be 100% efficient. Entropy always wins. Another example, bearing friction. Now let's look at a bearing, a simple but perfect example. When it rotates, some energy is lost as frictional heat. Even the smoothest bearing with the best lubrication will always waste a bit of energy as heat. That heat represents disordered motion of molecules, increased entropy. It is nature's way of saying you can get perfectly efficient motion forever. For a simpler example, paint mixing in water. Imagine a container filled with clear water. You pour a little pink paint on one side. At first, the paint stays together. That's an ordered state or low entropy. But soon, the paint starts spreading throughout the water. After a few minutes, the whole container becomes evenly pink. This is higher entropy because the molecules are mixed and disordered. If you keep adding more paint, the solution will eventually become saturated. The color can't spread anymore. That means the system has reached maximum entropy, maximum disorder. Just like this, every natural process, from mixing liquids to running machines, tends to move from order to disorder. So, what do we learn? Entropy means disorder or randomness. It's why energy spreads out and machines lose efficiency. Engines, bearings, and even a glass of water follow the same rule. Entropy always increases. It's the reason why perfect efficiency or eternal motion is impossible. If you enjoyed learning how entropy shapes the world of engineering, hit that like button, drop a comment on what topic we should explain next. And don't forget to subscribe to AxlePoint for more industrial and engineering basics made simple. Until next time, stay curious and stay mechanical.